Okay, this is a super quick example on how to transfer data from an analysis done with a vision sensor on the Vision Sensor Configuration Studio to Rockwell PLC. So in this case, what I'm doing is I'm evaluating a cap. This is the cap of a bottle, and I'm looking for this feature right here. So what I did here is I created this detector, and under the detector, I have this angle tab right here where I can specify what's allowed in terms of rotation, right, for this feature. So right now I have it set to -20, from -20 to 20. Um, so what I need to do is I need to transfer the actual degrees that are captured by the image, transfer those degrees to a Rockwell PLC. So I right now I have a live image, as you can see that there's my hand right there. And what I can do is I can start turning this, and let me switch this to results here. You will see the angle right here, so -3.8 over here. So if I start turning this feature, you'll see that that angle changes, right? So right now I'm making it positive, and I turn the other way around, and it's negative. All right, so let me set it to around 0. That's fine. And what I'm going to do now is I'm going to show you how to configure the output. So right now I just have that detector, just looking for that feature. I'm using a detector type contour, and this is what I'm detecting here. I'm not going to go into the details today. Um, so the basic things that you have to set up here in order for you to communicate to Ethernet IP is under interfaces. Here you have to enable this checkbox. After you did that, then you jump into the Telegram and tab, and then here just make sure that you have the same settings as I do. The most important thing here is the payload. So the payload is what you are transferring on that Telegram that you're sending over Ethernet IP. So right now, what I wanted to transfer is the angle, right? If you wanted to add another one, you just click in here in the positive sign, select which detector. So this you have these three different options because I have an alignment tool. I have one detector, but you could also have 5 different detectors, right? So for example, on the alignment tool, I could also transfer the angle if I wanted to. Or for the detector, I could also transfer, I don't know, position on X or position on Y. So meaning this point right here, the offset of this point. If suddenly it moves over here, then I will get that offset. But for now, I just want the angle. Okay. So now the next thing before I start is I have it on their job here. I have it on free run. That means that it's constantly acquiring images. I wanted to set it to trigger. So right now it's only going to acquire an image whenever I trigger it, right? If I go back to the output, all of this is fine. You don't have to change anything else here, and then you just click Start Sensor. As soon as you click Start Sensor, all of the configurations that you did here are downloaded to the sensor, and it's just running right now. So now, if I jump to let me get this out of the way. If I jump to the Rockwell software, so what I did here is I just added this generic Ethernet adapter. Let me open it so you can see the configuration. So I just named it, I specified the IP address for it, and then this is specified on the user manual. So let me open that so you can see. Mm, so if I go here and I go to the Ethernet IP configuration here, there is a section here that specifies that the assembly right here. So section 5.7.3, it says that the request is 344 bytes long and the response is 444 bytes long. So that's why I have this 101.444, 100.344, okay? And that's about it. I'm using unicast, and that's it. Once you configure it that way, you should be able to have this connection to the SPSI sensor. And then the other thing that I did is I added this AOI, so you can get this from a Festo representative. You can get this AOI, and what I'm doing here is this AOI, I just mapped the output and the input. So meaning, let me get offline. So I can show you, meaning that I'm just getting the whole data from the generic module for the inputs, and the same thing for the outputs, right? And here for these variables, I just declare the variables as any variable, just assign a name to it, and that's about it. The other thing that I did here is I added this copy instruction. Why? So this is, I think this is the most important part here for you to understand. If you remember on the software, let me go back here. On the software, we had this telegram, right? And we specified a payload to it. So right now I'm transferring one piece of information. Now, if I scroll down through the user manual, scroll down, scroll down, scroll down. Let me see where it is. Right here. So under this section, assembly response, you scroll down, you're going to see on byte number 244, scroll down, right here. So on byte 244, this is where the results of the payload are start to be transferred, right? So all data on payload are described on starting from this byte. So I get this out of the way. And so that's why I'm using this copy instruction, because what I'm doing is I'm transferring 4 bytes right here. So you can see length 4, starting from 244. I'm transferring those to a local tag that I created, which is just, this can be my tag or whatever. I just called it my data 244. And this is of type double integer, right? So that's basically what I'm doing. Now, if I go online with this program, mm, there, I'm online. So now I want you to see the following. I'm going to put this, let me put this side by side so you can see. Uh, oops, hold on. It's loading. There. So right now my data 244, it's saying 47, right? Now, let me, this is the angle right now. So it should be 0, right? So I'm going to trigger it, and you should see this image change over here, right? So I'm going to trigger it with a 1, and you probably saw a difference there. Let me do it again so you can actually see a real difference. So I'm going to change the position of the bottle, trigger it, and you saw the change there. Let me switch it back to 0, or change it back to 0 to trigger it again. And not quite, but right now the angle is minus 5.2, right? So I should be getting that minus 5.2 here, right? Of course, I don't see it on the raw data coming from the SBSI, because this is reading just 1 byte, right? That's why I had this copy instruction, because this way, let me show you why. So if I go to byte 244, right here. Oops, let me see if I can close this. Right there. So if I go to byte 244, you see that it's just giving me some information, right? The problem is that that piece of information is comprised of multiple bytes. In this case, it's 4 bytes. So from 244 all the way to 247. So 1, 2, 3, and 4. That's 4 bytes. That is exactly why I'm using this copy instruction, so I can transfer those 4 bytes into one single variable of type dint. So now on this variable, I'm looking at an actual value of minus 5191, which is, if we transfer it to this value displayed over here, this is a rounding that number, right? So if I change that, the position of the bottle again, let me change it. Oops, 0. Let me change it to see if I can make it around 0, 1. So now it's 2.9, 2.1, getting close. 0.3, that's close enough. So now I want you to look here. So now the value is 311, right? So rounding to that value showed here, that's zero point 0.3. So that's basically how this thing works. And if you want to use it with any other kind of payload, you can do it. So let me just do a test here. If I added instead of this angle, what if I wanted to show the position on X? Let's do that. So, and make sure that you select the right detector, right? Because by default it's selecting the first one, but I want to check actually this detector. So position X 250. Let's do the trigger again. 1. So right now is 252.8, and that's right there, 252.8, right? And you just have to do a division there, and you will get your value. So if we change that again, let me move the bottle a little bit right there. So that value should change. There we go. So now the value is 353.7. 353.69, right? Or sorry, 353,696, which is approximately that value. And that's how it works. So whatever you have here on the output, whatever you have here on the first one, it's going to start from byte 244. Let me bring that thing here. Where is that document? Hold on. Here it is. So whatever you bring here, it's starting from here, 244, count 4 bytes, and then that'll be the next one. So if I had another one, like let's say detector 1 angle, this one will start where? 248, right? This one, because this one is 244, 245, 46, 47. That's 4 bytes, and then the next one is 248. That's where this one will start, and so on. The more that you add, the more the offset that the more offset that you're gonna have. That's basically how this telegram works. Thank you.